Today's notes are about solving systems of linear equations by elimination. So far we've learned two options or two strategies that we can use to solve systems of equations. The first one was by graphing, where you find the intersection point between the two lines. And the second one is called substitution, where you pretty much take one equation and you substitute it into the other equation to solve for a variable. So with elimination, our goal is to eliminate our variable. So we'll jump right in with example 1. It says solve the system of linear equations by elimination. So with elimination, we're looking for one term in each equation that has a matching coefficient. So just to review, the coefficient is the number that's in front of the variable. So the coefficient of 3x is 3, and the coefficient of 2y is 2. And the coefficient of this negative 2y is negative 2. So we're looking at a variable that occurs in both equations that has a matching coefficient, and it's okay if they have the same sign or if they have different signs, and we'll talk about both different situations. So for example 1a, 3x plus 2y equals 4, and 3x minus 2y equals negative 4. So it's actually better in this case, or at least a little bit easier, if our coefficients are the same number but opposite signs. So we can see with our x's in both equations, they both have a coefficient of 3, but they're both positive 3. And then for our y's, one has a coefficient of positive 2, and in the other equation, the y has a coefficient of negative 2. So this is actually ideal, where they're the same number but different signs. So since the y has a positive 2 coefficient and a negative 2 coefficient, we're going to eliminate y in order to solve for x. So in order to eliminate y, I can just add my two equations together, and the y term will disappear because we have the same coefficient but with opposite signs. So 3x, if I want to add these two together, I'll just add them vertically. 3x plus 3x, that's all together 6x. And then 2y plus a negative 2y, those are opposites of each other. So a positive 2 plus negative 2, that's 0. So those just cancel out. And then we can bring down our equal sign, and positive 4 plus negative 4, that's 0 also, because they're the same number but with opposite signs. So when we add them together, we get 0. So just to go through that one more time, 3x plus 3x, that's 6x. Positive 2y plus a negative 2y, those cancel each other out because they're the same number but different signs. Then we can bring down the equal sign, and then positive 4 plus negative 4, that's 0 because they're the same number but opposite signs. So when we add them together, we'll get 0. So now our equation is 6x equals 0. And if my goal is to solve for x, I need to undo the 6 that's being multiplied by it. So I can divide both sides by 6. And then 6 divided by 6 cancels out, so I'm just left with x. And then 0 divided by 6, well, 0 divided by anything is still 0. So we end up with x equals 0. But we know with systems, our final answer is written as x comma y, or it's a point. So in order to find the y value, I have to take my x equals 0 and plug it into one of my original equations. It doesn't matter which one, whichever one you think is easier. So I'm going to use the first one. So 3x plus 2y, I'm just going to rewrite it right here, equals positive 4. And then if I'm saying that x is equal to 0, I can take that 0 and plug it into the equation where x is. So instead of 3 times x, it becomes 3 times 0. And then we bring down the rest of the equation, it stays the same. So plus 2y equals 4. And then now we can simplify this equation to solve for y. So 3 times 0, that's just 0, plus 2y equals 4, just bringing down the rest of the equation. 0 plus 2y is still just 2y. So altogether 2y equals 4. And then now if I want to solve for y, I have to get y by itself. Right now there's a 2 being multiplied by the y. So to undo that multiplication of 2, I'm going to divide both sides by 2. And then 2 divided by 2, that cancels out. I'm left with just y on the left side of the equal sign. And then 4 divided by 2, that's 2. So we end up with y equals 2. And then for our final answer, we'll just write it as x comma y, so as a point. So x was 0 and y was 2. So our solution is 0, 2. And then for example B, we have 3x plus 2y equals 7 and negative 3x plus 4y equals 5. So now we can see that the x's are the only ones that have the matching coefficients and they have opposite signs. So we can eliminate the x's by adding the two equations together. If we add the two equations together, we're not going to be able to eliminate y because they don't have matching coefficients. One is 2 and 1 is 4. So when we have the same coefficient, the same number in front of the variable, and different signs, we can eliminate that variable by adding the two equations together. At some point, if you have the same number, but the same number and the same signs, you'll have to eliminate by subtracting the lower equation, and we'll talk about that later on. So when I add these two together, we'll just add them vertically with all the like terms. So 3x plus a negative 3x. That cancels out. So 3x plus negative 3x, that's kind of the same thing as 3x minus 3x, so that cancels out completely. And then 2y plus 4y, altogether that's 6y. We're just adding the coefficients, the number in front. Bring down my equal sign. And then 7 plus 5 is 12. So now I have 6y equals 12. I want to get y by itself in order to solve for it, so I'm going to undo multiplying by 6 by dividing both sides by 6. So 6 divided by 6 cancels out, and on the left side of the equal sign I'm just left with y, and then equals 12 divided by 6 is 2. So y is 2. So we found 1/2 of our final solution. To find the other half, I just need to take that y equals 2 and substitute it into one of the original equations. Doesn't matter which one we do, so I'm going to pick the first one. I'll rewrite it over here. So 3x plus 2y equals 7. And then if I'm saying that y is equal to 2, I can take that 2 and I can substitute it into the equation where y is. So I'll rewrite the equation just replacing y with 2. So 3x plus 2 times, instead of 2 times y, it's 2 times 2 equals 7. And then I'll start to simplify. I can multiply the 2 times 2. So 3x plus 2 times 2 is 4 equals 7. And then now I have a 3 being multiplied by x and a 4 being added to x. So if my goal is to solve for x, I want to isolate it. So I can undo this plus 4 first. I'll bring down the 3x. So I'm going to undo the plus 4 by subtracting 4 on both sides. 4 minus 4 cancels out. I'll bring down the equal sign. Oops, sorry, this should be a minus, because we're subtracting 4 from both sides to keep the equation balanced. And then 7 minus 4 is 3. So then we have 3x equals 3. I want to get x by itself, so I have to undo multiplying by 3. I can undo multiplying by 3 by dividing both sides by 3. So 3 divided by 3 cancels out. I'm left with x equals 3 divided by 3 is 1. So I got x equals 1 and y equals 2. That means my final solution is 1, 2. we write it as a point.